Today we are going to review the property chart of real numbers. You have probably studied the properties throughout your education, but you really need to understand when to use them and why to use them in algebra. So if you would please fill in your notes with me as I go along. The first thing we're going to talk about is commutative. And if you notice, the root word in commutative almost says commute. So if you will write down the word commute and think about what that word means. The word commute actually means to change locations. So everybody in this classroom today actually commuted to school. At some point, we made it to school. We changed locations. If you were at home, you made it to school. At the end of the day, we will commute back home. So the way that I remember this is commute. So if you will please draw a car. It is okay if you cannot draw a car. So here's our little car, and we drive to and from school. So notice the C, commute, C, change locations, C, car. We are going to change locations. Now, that's the way to remember it, but this is the property in action. The commutative property of addition looks like this. A plus B equals B plus A. Notice that A and B have changed locations. So 3 plus 4 equals 4 plus 3. They've changed. Now, what makes it a property is that 7 equals 7. So in math, you can honestly switch addition. The locations can switch, and you will get the same exact thing. Now in algebra, sometimes it may not be as clear to see. I have x plus y in parentheses plus z equals y plus x plus z. Now if you notice, the x and the y changed locations. So you can have a property within an expression. Notice the z did not change. So commutative property of addition is when you can change the location of numbers and not change the value. Now it acts the same way with multiplication. A, B equals B, A. You have two numbers being multiplied. You can switch the numbers locations around and it does not change the value. For example, 2 times 3 equals 3 times 2. The numbers changed locations, but 2 times 3 is 6 and 3 times 2 is 6. And that illustrates the commutative property of addition and the commutative property of multiplication. Please notice you do not have a commutative property of subtraction or division because you will get the incorrect answer. Only addition and multiplication. Now, associative property of addition and associative property of multiplication. The root word in associative, if you look here, is you can almost get the word associate or associate. Now, that word means a group together. Now, if you've ever been to the dentist office and it will say the dentist name and associates, or a lawyer's office, the lawyer's name and associates, what that means is it is a group of dentists or a group of lawyers together and they're grouped. Okay? So the little picture that I want you to draw here is just 3 people. Okay, so here is a group of friends. They are grouped together. And the point behind associative property is it does not matter which way you group them. You're still all in a group. So let's look at it for addition. You have A plus B plus C. And if you group A and B together, you will still get the same thing if you say A plus B plus C and you group B and C together. Now notice, none of the locations changed for the numbers. The only thing that changed was the grouping. So let's look at this as an example. 3 plus 4 plus 2 equals 3 plus 4 plus 2. If I group 3 and 4 together, I get 7 plus 2, which is 9. On this side, if I group 4 and 3 together, or 4 and 2 together, then I get 3 plus 6, which is still 9. So it does not matter which way I group those. Now, it's the same thing for multiplication. A, B, C equals A, B, C. So now we're multiplying. If you group together A and B, or B and C, it's not going to affect the value. So for example, 2 times 3 times 4 equals 2 times 3 times 4. If I group together 2 and 3, I get 6 times 4, which is 24. If I group together 3 and 4, I get 2 times 6, or actually 12, excuse me, and I still get 24. So you can see here that it does not affect the value. So just like if you were going to ask your friends to go to the mall with you, it doesn't matter what order you give them. As long as you're a group together, it does not affect the outcome. Now, the next property is called the identity property. Now, the key word here is actually identical, okay? So if it's identical to something, then the key to remember is that it stays the same. So it'll always stay the same. Now, remember I for identity, okay? So the way to remember this is to think I am important. I am important and I will not change. Okay, you are who you are identical. Now, the identity for addition, think of any number that you can add to a number and get the same number back. Well, of course, that is 0. So the property reads A plus 0. Well, anything added to 0 gives you the same thing back. So adding 0 is your additive identity. And sometimes you will see it expressed that way. So you want to remember that it is the additive identity. So think of it this way. 4 plus 0 is 4. I did not change. XY plus 0 is XY. I did not change. So anytime you add something to something and you get the same thing back, that would be adding 0, and that is the additive identity. Now, the next one is the multiplicative identity. And think of what can you multiply a number by and not change the value? Well, that is 1. So A times 1 equals A. 10 times 1 equals 10. Notice, I am important and I did not change. And this is called the multiplicative identity. Remember that word identical. No matter what I do to it, I get the same exact thing back. Now, the next one is the inverse. And the inverse, the easiest way to think about this is inverse operations. They are opposites. And if they are opposites, what do they do to each other? Well, they cancel each other out. So they cancel each other out. Now, think about this. Okay, what cancels out 3? Well, if I have 3 and I add negative 3, they cancel each other out. So the addition property for inverse is A plus its opposite, which is negative A, and that produces a 0. So they're opposites. 20 plus a negative 20 equals 0. And that is called your additive inverse. And we do additive inverse operations all the time when we are solving equations. Now, the multiplicative inverse, you kind of know it for another name. That looks like this. A times 1 over A equals 1. And you know this step right here as the reciprocal. The reciprocal will undo the original A. So 3 times 1 over 3 gives you 1. Now, they cancel each other out, therefore they are inverse operations of each other. Now, last and certainly not least is the distributive property. The distributive property means exactly what it states. The key word here is to distribute. And to distribute something means to give out. And not just give out, but give out to each. If I were to distribute candy to you, I certainly would not want to leave anyone out. So you've got to make sure that you're fair and you give out to everything. Now, this one's a little different because it's not really an addition or multiplication property. So notice here, this stops, and this is what it is. You have A times B plus C, and what happens is that you distribute the A to each number inside. So this would actually be AB, because A times B, plus A times C. Now you can have addition, and you can also have subtraction. So you have AB minus AC. Now, the math behind the distributive property looks like this. If I have a 3 times 4 plus 2, there's two ways I can work this out. I can distribute, which would give me 12, plus 6, which would give me 18. Or I could actually solve this with order of operations. 4 plus 2 is in parentheses, so this will be 3 times 6, which is 18. Notice I get 18 either method, and that's why it is called the distributive property. Now, the next thing I want you to do is flip your paper over and try to apply all of these properties to the worksheet on the back.